Hi, everybody. Thanks for coming here. My name is Luca Perrozzi. I am a solution architect at AWS. And here with me on stage, we have...
My name is Michał. I'm a principal software engineer at Beekeeper. And I'll take this later, and I'll give it back to Luca, please.
Thank you. So, as per title, this talk is about patterns in using AI/ML when we want to build a SaaS product. And why do we want to, let's say, marry SaaS and generative AI? There are multiple reasons. First of all, you can see SaaS as the future of apps. We have seen a rise of adoption of SaaS deployment patterns. And at the same time, we have seen an increase of generative AI adoption, which is at the forefront of AI. So this is a good match, if you want. At the same time, both SaaS and generative AI can provide targeted tenant experience, this customization that our customers are really searching for. And we want to make sure that each tenant has its own, let's say, expectation fulfilled. This is more of a business topic most of the times, regarded as, but packaging and tiering opportunities are a way to pair business needs to, let's say, technical deployment techniques and also how to make the application in the background. So this is also a topic that we will cover. SaaS is all about efficiency. We really want to make sure that we have higher margins, we have scalability. And to do this successfully, typically we need operations and business insights at our fingertips. And the collection of the data is something that most of the applications should have, SaaS application in particular. And we have seen that generative AI can actually help in quickly creating these insights with less effort. So this is also a good fit. Tenant onboarding optimization. So we have seen several customers that use generative AI to accompany customers through their journey in their SaaS application. When to propose a switch in the tiers, prevent churn, make sure the customer success talks to the people in case there are problems. Okay? And last but not least, both SaaS and generative AI try to provide these richer multi-tenant capabilities to differentiate your application from the competition, in essence. So to set the stage, when we talk about generative AI, but also AI/ML, there are many use cases. We will focus on the generative AI, but this is a pattern that can be extended to many other use cases. We will talk about foundation models. And how to access foundation models or how to use them passes through the providers. There are both closed and open source models. There are many model providers, including Amazon. We have Hugging Face, which is a very well-known hub for open source, mostly open source models, to be uploaded and used with a click button. Foundation models need to be incorporated into services that create this API layer that can be integrated into your SaaS application. And in particular, we have two services inside AWS. You can think about Amazon SageMaker, that is a bit more on the self-managed side of things. And we have Amazon Bedrock, that is an API layer, so you pay just per use. On top of these models and services, we start to have these customizations. These are dashed boxes, and they do not span the full, let's say, left and right, because they are optional. And we want to apply them whenever needed, just for a certain number of customers, not for all the tenants. It's something that you will need to decide. So fine-tuning is a pattern that we have observed a lot. It requires a bit more data science, machine learning capabilities, but especially when you have super specific domain information, knowledge, wording, this is something that you might want to consider. At the same time, without going full, let's say, through the fine-tuning, we have seen an increase of adoption of context that can be injected into your application through stateful let's say, memory patterns, and this retrieval augmented generation, or RAG, that is nowadays everywhere, very prominent, and we will talk about it in detail. So all this is the foundation of the generative AI or the AI/ML part integrated into your SaaS application. So let's recap a little bit how the experience, because this is all about how the generative AI experience will fit into your SaaS application. So let's take a very basic example at the simplest essence. You have a customer, that interacts through a query of any form with the application. The application will go into, let's say, a stateless service, in this case Amazon Bedrock, that will elaborate an answer, which will be propagated through the application to the customer. And in this case, there is a shared common experience, because to a very similar input, there is going to be a very similar output. So how do we take this to the next level? How do we make sure that in a SaaS multi-tenant application, we can have some context that is tenant-dependent? We want some tenant-specific augmentation. Typically, you need to have data that are specific to this tenant, whether it's domain, whether it's session. You will need to store them into databases that are vector databases if you want to have semantic search, or even just a DynamoDB or SQL databases of the sort. So once we have enhanced our prompt, that is the piece of information that will be sent to the models or the services, in this case Amazon Bedrock, then we will be able to get this tenant-specific response. Okay? So this is, in essence, the pattern of and the experience that users of a SaaS application will have when using a generative AI application. Now, we can think about how to deploy, for instance, this tenant-specific information. No? And if we have a specific tenant, let's make an example. We are in the e-commerce space. We have a tenant that has an e-commerce of tools and wants to propose some product recommendations based on their preferences. Okay? So when a tenant interacts with their application, we'll need to access the application, a tenant-specific data, in this case siloed. And with this information, we will augment the prompt with tenant attributes, and we will make sure that, for instance, the user received the right suggestions. Another tenant will need to access different set of information. In this case, could be an e-commerce about golf. Okay, still siloed, but we know, because we have SaaS patterns, not just as generative AI, that we can have also different deployment approaches. In this case, a pooled one. Pooled means that all the data from different tenants are contained in the same table. And you need to be very careful in making sure that the tenant can get only the correct data associated to its partition key in this case. This, for instance, could be an e-commerce that sells clothes. So we have seen already that siloed is more on a premium, is a bit more costly kind of deployment, but it guarantees also easier level of security. And the pooled can give you access to more optimization, cost saving, but requires a bit more care on the security side. So taking it also to the RAG. RAG, we mentioned, is about creating a vector database most of the time. You have some data that needs to be transformed into vectors through embeddings. There are plugins and techniques that allow you to search for different documents that are similar. And we have also very different services in AWS that can serve for this purpose. We have Amazon Kedra that is fully managed. We have Amazon OpenSearch that also comes in a serverless fashion. We have Amazon Aurora, which is plain SQL. And also we have other services in the area, not necessarily of the vectorization, but also on the personalization. If you want to recommend products based on the past history, then you would use something like Personalize. And this would still be some kind of RAG, Retrieval Augmented Generation pattern. And so, depending on or independently of this, of which service you will use, you will still need to ask yourself, how will you partition the data? Will you go for pooled versus siloed? How this will impact the partitioning approach? How the isolation will be treated? How do you treat the noisy neighbors? So you see, we are still in the SaaS space, so we still have all the construct that you need to take care about the SaaS space, but in this case, in a different context, which is the generative AI one. So, in essence, when we have a vector database that needs to be populated with the data, the first thing that you need to have is collect your tenant-specific data. And as I will show later, this could be the hard part, the most difficult part of your job. Typically, this data needs to be processed. There are many services out there, your pipelines that probably already have in place. These are examples of AWS Glue and Amazon EMR that are services that serve the purpose of data processing. Then you will need to create these embeddings and store them into services, and in this case, represented is Amazon OpenSearch. In this case, it's also siloed for 2 different tenants. This entails some complexity, and this is why services like Amazon Bedrock, to some extent, are becoming the one-shop stop that integrate more and more feature to do the heavy lifting for you, to have one single place to control the whole generative AI and RAG experiences. I will not mention agents, because we don't have time, but also agents are embedded, for instance, inside Amazon Bedrock. So from Amazon Bedrock, you can decide where the data source is. Let's say it's in a bucket in S3. You can spin up an instance of a service like Amazon OpenSearch serverless to store the data. You have the possibility to create a knowledge base that will be integrated with the OpenSearch serverless. You will have in the same service, still in the same service, the possibility to choose a model for the embeddings and then store the data and also retrieve them. So Amazon Bedrock, to some extent, is a good choice when you want to not to do too much heavy lifting and you want to delegate it to a managed service, also in this respect. So once you have created this RAG environment, you still need to route your tenant requests. So you will have your tenant that needs to be, let's say, enriched. The request of your tenants need to be enriched with this tenant context. So once the request will reach your SaaS application plane, will go through the service, there is still this control plane that will be used to get this tenant RAG context that, for instance, will point to the specific tenant database through which we will create this prompt. At the same time, from the control plane, we will need to get the kind of model ID that we have for each of the tenants. And with this model ID, we will forward all the information to a service like Amazon Bedrock to get our response. Again, is conceptually extremely similar to any other SaaS approach. But this is the specific case to have an experience with generative AI. And Amazon Bedrock, again, is at the forefront. Whether you want to use fine-tuning or RAG, there are no absolutes. You can use fine-tuning for all the tenants, all the fine-tuning, let's say, all the same fine-tuning for all the tenants. You want to split for a given tenant. You want to use agent, knowledge bases, RAG configuration. This is where you will need to think about how you want your tenants to experience your application. And again, as I anticipated, the hard part is when it comes to the data, because the question that sometimes is not obvious to answer is where is the domain and the tenant context for your solution? Is it coming from generic industry domain context? Is it in the tenant application data? Is it specific to the custom tenant context? Do you want to use fine-tuning, RAG configuration? These are the questions that you will really need to figure out. And you can experience, but then you will need to take a decision. Switching a little bit gear, let's talk about tenant isolation, another pattern. No? Again, it's very similar to all the other SaaS, let's say, related approaches. What is the problem? We have RAG vector databases. We have fine-tuning endpoint, for instance. We have different services that need to be reached. And we just need to make sure that a tenant cannot access information from another tenant. Again, there are very similar patterns that you might be familiar with. For instance, you have an authentication that provides some form of token through which, let's say, the SaaS solution propagates this information to a service like IAM. IAM allows the the API calls, to do an assume of the role, which is very tenant-specific. And in case we want to access some pool tenant data, we will need to come up with an item level policy. So we will need to make sure that there is a row level security in place. But again, you will gain efficiency and you will optimize cost if you use a pool model. When it's about siloed, the isolation is a little bit somehow easier because you will just need to isolate at resource level policies. Let's come now to I think the most important part of this talk, at least for what regards my part, which is the tiered experiences, because there is a little bit of additional complexity, and there are also new ideas coming out on how to make sure that generative AI matches your pricing and your tiering. So for sure, you want to have very likely different tiering strategies, and how you divide the tiering makes a whole difference. You can have throttling, you can have a way, or you need to have a way to limit noisy neighbors, you need to align the cost with the consumption, and you need to avoid service saturation. The worst case scenario would be a basic tier customer, tenant, that would actually saturate all the requests from the generative AI services, and the premium ones would be left with, let's say, a small bandwidth, if you want. So, in this case, how do you throttle requests could be seen through an Amazon API gateway. This is a service that has this kind of feature embedded, and is typically a natural choice. When using Amazon API gateway, you can think about authorization. This is a typical SaaS authorization that you need to put in place and is embedded inside the API gateway. But generative AI, and this is really the important gist, adds a little level of complexity, which is how many tokens, how complex is the query that I'm gonna, let's say, ask or propagate. So there needs to be in place an evaluation, not only am I authorized to reach this service, but also am I compliant with my limits due to my tiering. So you will need to mix and match and create some kind of authorizer policy to then access the service. So think about how you assess the complexity. Token length, maybe this is a good pattern. How you define the boundaries of the complexity. Do you want to limit also in terms of frequency of the calls? Or would you like just to limit in terms of length, for instance? And what are your SLAs? So a very simple and simplistic way of doing is tiering through foundation models. You can say the basic tiers only have access to a cheaper model. In this case, we can think of Claude Haiku, which is very cost-effective and also pretty powerful. But then my premium tiers will be having access to another model which is more powerful. This is a simple way. At the same time, you can be more creative. Okay, do you want to align the pricing to the experience and the value-based? Do you want to let basic tier customer not have customization, and you offer customization for the premium tier? A choice. Do you want to have an SLA-based pricing? The throttling levels are different from basic and premium tiers. Do you want to have a consumption-based pricing? Consumption-based pricing is possibly the easiest to put in place, but also the one that aligns a bit the least with the value, because the customers pay per user, but you can capitalize a bit more if you adopt a value proposition pricing. So for sure, there's going to be a mix and match of all this, and it's up to you then to explore your possibilities. See siloed versus pooled. Again, you can have tenant or no tenant refinement, configuration on demand. You can have provision throughput for the premium tier to have better SLAs, and you can have different charge. I will skip a bit this slide. I will go fast. So the important bit in this respect is that if you have an application playing with different tenants that need to access services, you will need to have some way to interject these requests and evaluate, for instance, the input tokens, because you will need to apply pricing and also throttling based on this complexity that we were talking about before. So after this evaluation, you can still propagate the prompt and the query to Bedrock. And at the same time, you will need to evaluate and capture the number of output tokens, for instance. So this is, for instance, a way to think about how to make sure that the costs are kept under control. And there are no specific, for instance, services or features that are inside Amazon Bedrock. We provide some examples that are hosted on GitHub as open source, but you will need to build some of these by yourself. And this will also need to be captured by the control plane, because of course you want to publish the tenant consumption as a part of this metric and analytics that you should have in your application. So last bit is that you are not alone. Let the tools that are available out there do the heavy lifting. There are libraries like LangChain that have evolved tremendously in the last year, and they have a lot of integrations also from different providers. There is Hugging Face that we mentioned already, and you can have access to a lot of models, but also libraries and tools really to enhance your experience, especially if you want to go, for instance, to the fine-tuning side of things. And Amazon Bedrock, we have agents, we have knowledge bases, we have guardrails, we have released many other features like the prompt flow. So, and also we have an SDK that is offered in different languages, programming languages, so that you can really build on top of what we provide and you don't need to start from scratch. So what I have told you till now is the AWS point of view, is abstract, is very generic. I would like now to take more attention, even more attention, to our customer story that will be told by Michael regarding Beekeeper and their experience in generative AI.
Thank you, Luca. So far we heard from Luca how does a generic application would look like, but let's look at our use case. So I'm here to tell you the story of the Beekeeper we took with the Gen AI. And this story, like previous one, is going to be accompanied with a lot of graphs. So there will be additional, if you thought it's going to be end of graphs, now it's going to be more of the graphs. So this is how our current architecture looks like at Beekeeper whenever we talk about Gen AI and we talk about talking to Gen AI LLM-related tooling. But it wasn't always like this. We started our journey, which was look way simpler. And I would like to, during this talk, take you on a journey, what steps did we take, and show you the patterns. The patterns, you can use them in your own application when you're building it to gradually, step by step, improve user experience, which users get. But before we start, a little bit about the Beekeeper. Beekeeper was founded in 2012, and we are a frontline workers platform. We are making sure that the 80% of the workforce, who are the frontline workers, are represented and they get valuable technical tooling, that they are not underserved, and that the tooling which are required to make their job done. So you can think that whenever we brought the Gen AI, we had to bring it to the people who just expect for tools to work. So we took this very granular, step-by-step approach. Some numbers, so we can also see what kind of scale are we talking about. We have over 500,000 weekly active users. 5 million users open the chat to talk to someone every single month. There's a 150,000 posts written monthly, and we have 85% adoption rates for thousands of our customers. And we just don't run it in one place. We have 4 data centers. So whenever we deploy, we talk here about deploying it to multiple data centers. So how did we get here? So whenever we talk about us getting to current Gen AI deployment, we started very small. We started with just Gen AI deployment, where we had nothing, no context, just pure Gen AI feature. Then when we felt comfortable with that, we actually added context to it. Later, we added the database, making sure that we can fetch data for the users. Later, we built a query engine and then custom prompts. But enough of talking. Let's see how the architecture developed over time and what you actually can use when you develop your application. So we started with the simple enrichment. So you can see that in the way that we started with a user sending information to the LLM and getting back the response. The important part for us was that Beekeeper is there since 2012. We have a lot of code which already brings a lot of business value to the customers, which customers trust it will work. So whenever we brought a new feature, we want to make sure that we can develop it very rapidly. And I'm not talking here daily deployments. I'm talking multiple deployments even during the hours, our rapid development. So the first step was to establish a contract between our business service and Gen AI specialized service, and then make sure that we obey this contract. Afterwards, we could deploy our Gen AI specialized service as often as we wanted to improve, get user feedback, and evaluate it more and more and more and more and more. When we felt comfortable with that, we felt like, why not to start adding a context right now? So to our Gen AI service, we added a context. The context pulled the information from the database. And as like Luca before said, important thing is that you separate the concerns. You make sure that the tenant data don't pass. So as you can see here, every actor can only access to their tenant database, to their database, which they can access to build a knowledge pool for the model. And this context receiver then injects the data into the prompt. But here came another problem. When we query the databases like a Postgres, MySQL, they don't really like to query themselves with the LLMs. LLMs like to work in the normal language, spoken language. And when we query databases, we usually would try to use certain tags, you would try to use certain equals, and not a human spoken language. So we brought a vector database. Vector database allow us to store the data as a vectorized option. Here, keeping not the data itself, but more its semantic meaning. And what we learned quite fast, that we get multi-language support almost for free. Because the only thing we needed to do is to use multi-language embedding model, and then we could query a data using German and get the data in English or other way around with multiple languages. So that brought another way of actually querying the data. But we started to learn another thing, that if you don't give enough context of the information what users are looking for, you might be looking for the wrong thing. Because how do we know meanings of the word? We know them mostly by the context and the words around them. Certain industries might use exactly the same words to describe different things. And we needed to counter it. And here are some of the examples where somebody might be querying something meaning completely different thing than the other person. So we needed to counter it in some way, to make sure that when our users, where our tenants are querying for the informations, they get informations which are relatable to their industry, that LLM is trained to make sure that it gives them relatable information. Because vector built on the wrong context will look completely different, even if it contains the same wording, because API means completely different. ROI means completely different thing. And as you remember, we don't solve the words, we solve the semantic meaning there. So if we don't do it correctly, we will have the wrong results. So we come up with the solution of something called global context. Every single tenant gets an own global context, which will be always injected into our Gen AI specialized service as a part of the query or the prompt to the LLM, making sure that whenever we talk about construction industry, we use the correct terms. Whenever we talk about hospitality, we use the correct terms. And that the users get predictable results which they want to have and don't end up with something completely off. But there's another problem. For 30 years, we taught users, if you want to query for something, query for tags, query for keywords. Don't use the whole sentence, because that's how all of the search engines are working. That's how all of the indexing things are working. So users are not really used to query in the way that the LLM models are trained, where the vector models are trained, which is question-answer. So they started to just use keywords. And we have a problem, because this doesn't vectorize as well as we really would like it to vectorize. So we brought something called a query expander. Query expander only, as you can see, goes before vector database. So whenever we get a certain data we want to pull, we try to expand them into a question. These multiple questions then go to our vector database and are used to actually pull the data back. And for context receiver, we still push the data normally to database, because here we don't need to expand on the context. Here we can use the keywords, here we can use the tags. We can use it directly with our existing database. We talked quite a lot about data. So I just want to make sure that everyone is on the same page. What kind of data are we talking about? In our system, when we talk about GenAI, we look at 3 different types of the data. Tenant configuration, this setup, how the tenant is configured, what kind of option has enabled, from what industry might it be. Then we have a database. This is all of the existing business data existing in the service and our domain services. And then we have a tenant context. Tenant context is generated on fly depending on the context of the query. So if you want to do the post summarization, it will look completely different than if you want to do, for example, post creation, or if you want to do a campaign creation, or if you want to generate example comments. And then you probably heard on a talk before, the hardest part in LLMs and GenAI is evaluation. How do we evaluate? How do we know that the response which we gave to the user is correct? LLMs are very much indeterministic, which means that we cannot create easy unit function. We cannot test all of the edge cases, what it will return. So we have to establish some kind of feedback cycle to get information from the users. This is what we did. And probably every single tool you're using right now, and it has some AI baked in, you will see this common thumbs up, thumbs down feature. But what happens when users press thumbs down? Why do they press thumbs down? We started to question ourselves, what's the reason? When someone press, yeah, I like this, what you gave it to me, it's fine. But if they don't like it, what did we do wrong? How can we improve on that? We started to see there is a black spot. There's a spot which we don't see, we miss completely, and we cannot improve our models further. So we brought extended summary, extended feedback. Whenever someone gives you a thumbs down, we ask for more details. Please tell us, what did you not like? And we start to gather this feedback more and more and aggregate, knowing what do people don't like about our GenAI. Is it like summary maybe is too short? Or maybe is it too long? Or maybe there was something we omitted? Or maybe there's some information which is actually false information in this summary, and that's why people don't like it. There might be different reasons, and different reasons might have a different weight. Like, you won't put the same weight to the hallucination of the information to someone complaining that the summaries may be a little bit too short, because they don't have the same effect on the users. And as we work with the frontline workers, we want to make sure that they have information they need, so we prioritize certain problems. And how did we do it? We did something which is prompt evaluation cycle and a mutation cycle. As you heard from Luca previously, you have option to fine-tune your model to make it better. But we saw that fine-tuning will not work for us. The problem we saw with fine-tuning is currently releases of models are so fast that by the time we clean up the data, we prepare them, and we fine-tune the model, there will be already 3 new models coming out, which might be cheaper, which might be better, which might be faster. So we thought, how do we make sure that in our small engineering team, we are capable of evaluating new models, new prompt, and making this all the time better and better? So what we came up with is this mutation cycle. How does it start? We have a coordinator, which is started through the scheduler. So scheduler can schedule it during the low time of the usage of our servers to make sure that we use the unused idle power. Then we fetch all of the synthetic as well as the organic data from our database. And the feedback you saw before, we also fetch it as part of it. Then we go to our evaluator and we ask the question, do you think that this part, for example, with the user feedback is correct? Is there, for example, is it too long? Is it too short? Can you tell me that? To make sure that we do not hallucinate the option, that we have a correct option, part of the information we send for the manual review. But also what we saw makes a lot of huge difference is using a different family of LLMs. And that's actually where Amazon Bedrock is helping us a lot, because we can cross-check. There's a lower chance that if you generated the result with a Claude and then you check it with a Llama, that they will both hallucinate the same things. They were taught completely different way, they're completely different architectures. They're probably, if something will happen to them, it will happen in a different place. So whenever we evaluate one model, we use another model for it. And then we send this result to mutate the prompt to our mutator. And mutator will say, hey, here I have some feedback. You missed this information for this event in the summary. How would you change the prompt to make sure that next time you will include it? And this will create multiple prompts which then will be set and fed again from the beginning, making this loop cycle where we can automatically evaluate new prompts as well as new models. Here's a simplified version of how does it look like. So as you see, we not only take prompts, but only take multiple models. So we take prompts and different models, we put them in the model selector, then validate them, and some of them are manually validated. And as soon as they pass through our evaluator, they will be then stored in a database for the further use. What we learned from that was actually super interesting. Different people have different preferences when it comes to spoken language, which seems obvious, but quite often we sleep on it. We don't notice it. So we sometimes get contradictory feedback, like, I like the summary for me, it was too short. Other person, oh, that was too long. Other person, like, I would like to have only bullet points. So what we could do with that is now start to aggregate all of these responses, all of these questions, or per tenant or per user, making sure that everyone gets a little bit more tailored experience. Though also making sure that whenever they press a thumbs down and they write something, they see an input, because next time they come to the application, they try to do summary, they try to write a post, they try to generate a comment. They will see that actually feedback from yesterday now is included there. So I have incentive as a user to actually write more and give a better feedback to teach application what do I like. And we don't have to do any fine-tuning. So we are not burning money of fine-tuning now per every single user. We're just mutating prompts, which for us is quite cheap to do, it's quite cheap to evaluate. So we saw quite a big uptake when users giving the feedbacks after we introduced this like aggregation per tenant or per user. And next thing is we started to think how we can optimize the cost. We don't want to run everything on like the biggest cloud, which costs money. Can we run things on a cheaper model? So inside GenAI specialized service, we started to think, can we route somehow the queries? Can we route them based on the complexity? So whenever we see a question which is like quite easy to summarize, doesn't have much details, or a post which is easy to read, we can route it to a cheaper model. We can route it to a faster model, giving a user better experience and not wasting precious resources on generating things longer and actually burning additional resources. So Query Router takes into account things like what kind of use case do I have and what kind of inputs do I have, and then deciding do I need to use the model 1, 2, or 3, depending how capable these models are, lowering the cost of deploying the Gen AI while still keeping the quality of the results you're presenting to the users very high. Because as they come with the more trickier questions, you'll be routed to the highest model. But if they come with something easy, we'll be probably routed to the cheapest one. And the last thing is also something which Luca mentioned. You want to make sure that you don't burn for the money. So maybe you have some customers who are on the free tier or they're on the lower tier. So you want to enable them, still give them this AI capabilities, or maybe just give them a sneak peek of this model capabilities without them burning a hole in your pocket. So as part of the specialized service, we added the model selector. Model selector just looked into tenants and said, like, oh, this tenant should work on this model. For us, it was also a matter of us being deployed in multiple regions, where some regions could use only certain models and other models not, making sure that we can satisfy needs of all of the customers and deploy multiple models, even if it's just internal model, because we always could alter the model selector, which one we choose. And with the tools like LangChain, we have a similar API for all of the models. So plugging in the new models doesn't take much time. Even without tools like that, you can write abstraction layers in just a matter of minutes. So that's it from my side. I'll give back to Luca for key takeaways.
I hope you liked the beekeeper story as much as I like it. So let's look at some key takeaways, okay? Using, fine-tuning, and RAG-enable tenant-specific experiences. This is at the key of the messaging, the message that we brought to you today. You need to identify where the customer data lies. You need to collect it, you need to process it, you need to use it, and this is where possibly you will need to sweat a little bit more. You will need to change approaches, whether you want a siloed, a pooled deployment type, how you want to apply isolation, partitioning. These are SaaS constructs that are still there even when it comes to generative AI. Remember that limitations like throttling and pricing are going to be influenced not only by the number of calls a user is going to do, a tenant is going to do, but also what we call the token complexity that Michael also explained with this routing, for instance, solution. And always think how you can balance your deployment strategies with Bedrock pricing models, for instance, using different models for different tasks. Last but not least, this is really important. If you are starting your generative AI journey, you might feel that this is a super, super fast developing area and you might not know where to start. Search for tools, search for the SDKs, search for ways to start from a working solution that maybe matches even just half or 80% of your needs, and then you can modify instead of starting from scratch. So this is it for what concerns our talk. This is a reminder of the fact that if you would like to upskill on the generative AI aspects, you can go on skillbuilder.aws. You can create a free account, and I think you will have up to 7 days free for free. So with this, we would like to thank you, and we would like to remind you a very important part. Please, if you can, complete the session survey in the mobile app before leaving the room. This is it from Luca Perrozzi.
Thank you so much from Michał, and please fill up the feedback form.
Thank you.